In the first video, we learned how to create header files and why we create header files and different CPP files. In this video, I am going to teach you topics constructor, destructor, and dynamic memory allocation. I will not I am not going to teach you everything in C++. I assume that you already know these topics of C++. My goal through these videos are actually to make you familiar with the way the codes are going to be written in our Qt project, and these are actually videos to revise those concepts, and a few little here and there concepts are there which you might not know or already know, which we will use, or the way that or those are the way the codes are going to be written in our project. That is why I am uh, making this short videos, few videos, actually 3-4 videos about C++ and those topics. So okay, let's continue today. So we have already done this about the header files and why we use these header files. Now moving on to constructor and destructor. And yes, this PDF, this is actually a short PDF. You will find this PDF in the link below in the description. So what is a constructor? A constructor is actually a very special function which has no return type, and its name is actually similar to the class name. It is used to initialize the object, and the destructor is actually opposite to the constructor. It is called at the end of the program when your object is out of the scope, and it destroys the object. It removes all the memory that has been allocated to that object. So let's see an example. So right here, this is the very basic example. As you can see, I have created a header file here too, and then a CPP file, and I am using this scope resolution operator, everything, so that you get familiar with the ways we are going to write code in the Qt creator. So here you can see in the header file we have defined a class called demo, and on the right side of the screen here we have a data member int n, and in public we have a parameterized constructor and a destructor. So there are various types of constructor. You already know this. They are parameterized constructor, default constructor, and copy constructors. If I go ahead and I write here maybe n is equal to 5, then it becomes a default constructor. It is also constructor overloading, but I'm going to remove that for now. So as you can see on the left hand side, that we have actually in this right hand side, you can see that I have defined, I have structured the class here, and the constructor destructor, and I have prototyped a function here too. This is the structure of the class. This is how we make the H file. Now in the CPP file, I have defined that constructor. I've used the class name, and then the constructor name is same as the class name, and I have defined the constructor. And you will see that here I have used the this keyword, because I have used the this keyword right here because the variable name is same here as the data member of the class. That is why I use the this keyword here. If it is a different variable, we do not need to use this keyword, but I actually use this keyword to show you why we use this keyword. So why actually we use this keyword? Actually in the project you will find this word used a lot of time. So actually what this signifies is, imagine it as you are standing in a classroom and you are introducing yourself. What will you do? You will say that my name is Rahul. I am from Delhi or some place. So what is this? You are describing yourself. So this keyword actually describes that object for which the function has been called or invoked. So this keyword this keyword signifies that object. The same way when you are speaking about yourself here, this signifies that this is the object which everything belongs to. I have also included this analogy in the PDF. You can find it right here. Refers to use similarly in C++ when an object talks about itself inside a class, like setting its own name. It uses this to mean me, the current object. Uh, So that is why I included this here. So this is a very basic example. You can see that we have also defined a destructor. Inside destructor you can also write things, but you don't need to actually. And then we have a show function which is going to print the value of n, which will be initialized by this constructor. So actually I should take example why we needed constructor, or why we defined constructor, or why it was included in the programming world. You might not know this. So if I make a C file right here, for example, maybe call it test.c, or maybe we don't need test file, I can just show you right here. Let's suppose we define a variable which is int n is equal to 5. What did we do here? When we defined the variable that this is n is going to be an integer, we at that exact time, in that exact line, we also initialized a value to it, right? We initialized 5 here, 5 to this 5 to n, while we were defining this variable. So actually what C++ wants to do is, it wants to make it object, the class, very much similar to the primitive data types. That is why you can see we use constructors here, like the same line where we defined the object, in the same line we initialized it with a value too. The same way we were doing it with int n is equal to 5. The same way we made the object and we initialized it. So now we should move to another example, uh, which is very important. uh, we are going to learn about member initializer list. So what is a member initializer list? It is basically a way to write a constructor. It is a different way how we write a constructor. If we go to this example right here in construct member constructor.cpp, and I take this file member constructor.h file. So in this file you can see I have actually same, everything is same. This is a header file on the right hand side. This is a header file. In we have two data members in in public. We have structured that constructor and destructor. It was almost same as this file, but here in the CPP file, you will see that the way we have defined this constructor is different. We have not written the code inside the curly braces. The place where we are initializing those values to this variable, which is n and m, is actually outside of the curly braces. It is actually before the curly braces, right? If I show you that file, before file, in that first file, we were doing it inside those curly braces, and here it is outside and before those curly braces. So this is how we make a member initializer list. And why do we do that? So the member initializer list, as you can see here, it runs before the body of constructor, and it is most efficient way to initialize members. And when we use constant member or reference member, it is mandatory that we use this type, this method, or we will get some error, as I will show you. If I go ahead in this example, if I make this int a constant, you will see we have no error. You will see we have no error, everything is working just fine. But if I go to this file, constructor.h file, constructor.h file, and here also I open constructor.cpp, constructor.cpp. If I go ahead and here I change this and to const int n, you will see we have an error here which says expression must be modifiable value, which means that if we turn any value to a constant, or we define a constant value inside of the class, then we need to use member initializer list method to initialize those values. So moving on, you should practice this, because you will see us using this type of constructor, and also you can define the inside the curly braces here too. Actually, you should know that in constructor we can also define local variables, because we are also going to define so many local variables, widgets and layouts, and create so many things inside the constructor of the class in the Qt project. So here also you can actually initialize anything. Here you can make a string std string str equal to, there is an this I should also include string right here, and I can also print it. So if I print this, you will see it, we are also getting hello as the message. So as you saw, we can also have local variables inside a constructor, and this is the way we use member initializer method to define a constructor. And here you can see we have more than one data member, so we have used a comma to separate that, and this is the way we did it. You can read this in the PDF too, right here. Now we will see in case of inheritance, how do we make, or how do we create this use, or how do we use this member initializer list in the case of inheritance. Again, I assume you would already know inheritance. So right here I am going to take example of single inheritance. This is single inheritance.cpp file, and this is .h file. Here you can again see I have a .h file. Here I have made the first class, structured the first class, which is the base class, which has one data member and a constructor and a destructor. And what I have done is publicly inherited that base class in the derived class, and here I have a data member int m, and I have a constructor and a destructor. Here you will see that I have actually two 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 variables right here, but I have actually one data member. Why did I do that? Because I inherited a base class init too, and I also want to initialize this particular data member with a value. That is why in the constructor of derived class I have two variables, right? So here in the .cpp file of single inheritance, you will see that we have included that header file, and here, right here, we have first defined the constructor of the base class. The base class constructor is right here on the left hand side. Here is the base class constructor. Uh, the same way we did before, the member in this ledger list, and then base class destructor. And right here, when we are defining the derived class constructor, here you will see that we have called the base class constructor right here. So before, how we used to do this, we used to actually write here that variable, maybe k or something was that variable, but actually n this cat, but here what we will do is we will call the base class constructor here. The first thing is we did the base class constructor, and then the m which is the derived class member got the value. So this is the way we do it in the case of inheritance. I have also included this in the PDF. If you go down, you can also create local variables written here about this pointer, and then okay. Now moving on to dynamic memory allocation using new and delete. When we use new, we can create memory at the runtime, and the memory is allocated in the heap section, and delete is used to deallocate that memory. You already know this. We can go to any example, maybe this example. What we can do right here is just remove this and create derived star obj is equal to, actually, do we have a show function? No, we don't have a show function. I should take an example where I can call a function. Here we have a show function, so here we will do that. Constructor.h file. So here I will quickly change this, remove this constant type. So right here I can allocate memory to it using new and then class name and then the value, maybe 5. This is how we do it. And after this, we are not going to call the function this way with using the dot operator. We'll use actually the arrow. We'll do obj arrow. So, and then what we have to do is we have to actually delete it. Delete obj. So if I run this, you see there is no error. So this is how we allocate memory using new, and this is how we delete memory using delete. So thank you everyone. I hope this few topics, constructor, destructor, and memory allocation using new and delete was clear to you. You can actually go and read this PDF. In the next video we will look at static member and static functions, and then inheritance and virtual functions, and then we will move on to CMake in that video after that, and after CMake we will start using Qt. So thank you everyone.